Imagine, you could control your another computer from your laptop, even if that computer is in another room, another building, or even another country. You can access files, run Linux command, start programs, and manage server, all without physically touching that machine. Sounds crazy, right? But here's the interesting part. How can you remotely control another computer securely over the internet without hacker stealing your data or commands in between? Well, this is exactly what system administrator, developers, cloud engineers, and cybersecurity professionals do every single day using a technology called SSH. SSH allows computer to communicate remotely in a secure and encrypted way. So in today's video, you will understand what SSH actually is, how secure remote access works behind the scenes, and most importantly, I will show you practically how to connect your Linux machine with Windows using SSH step by step. So by the end of this video, you won't just understand SSH, you will actually be using secure remote access yourself. Let's get started. Back in the 1990s, remote access already existed. Universities and companies were connecting computers over networks to manage system remotely. One of the people working with this system was a Finnish computer scientist named Tato Jalonen. At that time, he was working as a university researcher, regularly connecting one computer to another over a network. But one day, something dangerous happened. A hacker had deployed something called a password sniffer across the network. A password sniffer is a tool that secretly captures usernames and passwords traveling through the network traffic. And the scary part was, back then, many remote access protocols were sending data as plain text. That means, if someone intercepted the traffic, they could literally read username, passwords, and commands directly. So while researchers and administrators thought their communication was private, hackers could secretly monitor everything. When Tato Jalonen discovered this, he realized something important. If remote communication continued like this, the entire system of remote access would become a massive security risk. So instead of ignoring the problem, he decided to solve it. He spent months studying cryptography, secure communication, and encrypted networking. And eventually he developed a new protocol called SSH, Secure Shell, a protocol designed to allow remote communication securely over an untrusted network like the internet. But now the big question is, how does SSH actually protect the communication? How can two computers communicate over the internet without attackers reading the data in between? To understand that, we first need to understand what actually happens when two computers communicate remotely. SSH or Secure Shell is one of the most essential tools for anyone working with the remote servers, especially if you are managing your own infrastructure or deploy application. So what exactly is SSH? SSH is a protocol used to connect to a remote computer securely. This connection is established over an encrypted tunnel, which means all data exchange between your machine and the remote server is protected from the eavesdropping or interception. In simple terms, even if someone is monitoring the network, they cannot read what is being transmitted. SSH is primarily used for remote command line access, file transfer, and secure tunneling of the network traffic. It is widely used by the system administrator and developers for tasks such as server maintenance, application deployment, and troubleshooting. So instead of physically accessing a machine, SSH allows you to control and manage it remotely in a secure way over the network. So how does SSH actually work behind the scenes? Well, the moment you start an SSH session, your computer, which acts as a SSH client, opens a network connection to the remote machine running the SSH server. And by default, SSH usually communicates through port 22. You can think of port 22 as the default door where SSH connection arrives. Once the connection is established, SSH creates a secured encrypted tunnel between your computer and the remote server. And this tunnel is what makes SSH so powerful. Because now, everything traveling between the two systems becomes encrypted. Your commands, passwords, files, and server responses. So even if someone intercepts the network traffic, they won't be able to understand the actual data. Now imagine this scenario. You are sitting with your laptop at home, but the web server you need to manage is running in another city or even another country. With SSH, you simply open your terminal and connect to that remote server. And it almost feels like your keyboard has been teleported to that machine. Every command you type executes on the remote server, and every results come back to your screen all securely through that encrypted tunnel. But throughout this video, we have constantly used the word secure. So the big question is, how does SSH know that the person connecting is actually authorized? Well, SSH mainly supports two authentication methods. The first one is password authentication. This is the simplest method where you enter a username and password to access the remote system. It's easy to use, but it's not considered the most secure option, especially if the password is weak or vulnerable to brute force attack. And that's why professionals usually prefers the second method, SSH key authentication. This method uses something called a public and private key pair. Let's understand how it works. First, the client generates two SSH keys on their local machine, a public key and a private key. The private key stays securely on the client's computer and should never be shared. The public key, on the other hand, is copied to the remote server. Now, when the client tries to connect to the server checks whether it recognizes that public key. If it does, the server sends back a small encrypted message, basically a random piece of data. The client then uses its private key to prove that it can decrypt and respond to that message correctly. The server verifies the response using the stored public key. And if everything matches successfully, the client is authenticated. And that's exactly what makes SSH key authentication far more secure than the traditional passwords. Once authentication is complete, a secure encrypted SSH session is established. From there, the user can run commands, manage servers, transfer files, and securely control the remote machine. And that is how SSH works behind the scenes. Now that we know how SSH works behind the scenes, let's actually use it in real life. In this demo, I will connect from a Windows machine to a Linux system using SSH. And first, we will use the simple method, that is password authentication. At first, open your Linux system and launch the terminal. Now install the OpenSSH server using this command, sudo apt install OpenSSH-server-y. If SSH is already installed on your system, you can simply skip this step. Once installed, we need to enable the SSH service. Then type sudo systemctl enable SSH. Now start the SSH service. To start this, type sudo systemctl start SSH. And to verify that SSH is running properly, type sudo systemctl status SSH. If everything is working correctly, you should see the status is active, which means SSH is now enabled on your Linux machine. Now we need two things, the IP address of the Linux machine and the username. To find the IP address, type IP A. Look for the IP before address in your network interface. Now to find the username, type who am I. This will display your Linux username. Now move to your Windows machine. You can open PowerShell or Windows terminal. To connect to the Linux machine, type SSH username @IP address you got from that Linux machine. If you are connecting for the first time, you may see this message. This happens because your computer has never connected to this server before. Simply type S and press enter. Now enter the Linux password. And just like that, you are remotely connected to your Linux system from Windows using SSH. Now any command you type here will actually execute on the Linux machine. For an example, type ls. You can list all the directories. Like this, you can do anything you want. Now here's something important. What we just did only works when both systems are on the same local network. But what if your Linux system is at home and your Windows laptop is somewhere else? This is where Tailscale become extremely useful. Tailscale creates a secure encrypted VPN tunnel between your devices, allowing them to communicate securely from anywhere. On Linux, install and start Tailscale using sudo tailscale up. It will provide a browser link. Open the link and log into your Tailscale account. Now download and install Tailscale on Windows. Log in using the same account you used on your Linux. Once both devices are connected, they become part of the same private network. Now type Tailscale IP-4. This will display your Tailscale IP address. Now again confirm SSH is running. Type sudo systemctl enable SSH. Sudo systemctl start SSH. And then find your username. Type who am I. Now from Windows, type SSH username @Tailscale IP. Enter the Linux password. And now, even though both systems are on completely different networks, you are securely connected through SSH. Now until this point, we have only used password authentication. But in real-world environments, professionals usually prefer SSH key authentication because it is much more secure. Let's set that up. First of all, we have to generate SSH keys on Windows. Open the PowerShell and type SSH-key gen. Now press enter through the default option. This generates a private key and a public key. The private key stays on your computer. The public key will be shared with the Linux server. Now copy the public key to the Linux machine. Enter the Linux password once. Your public key is now stored on the server. Now try connecting again. Type SSH, your username @IP address. And this time, SSH log you in without asking for the password. Because now the server authenticates your identity using cryptographic keys instead of passwords. And since the private key never leaves your machine, this method is significantly more secure. In this way, you can simply connect your Linux machine to your Windows computer. And that's how SSH works. From understanding the security problem behind remote communication to encrypted tunnels, authentication, and finally connecting to a Linux machine practically from Windows. You have now seen how professionals securely manage systems from anywhere in the world using SSH. Now if you enjoyed this video and want to understand networking even deeper, make sure to check out my previous video where I explained how DHCP works behind the scenes and how to create DHCP server in Cisco Packet Tracer. And if you really want to build a strong networking foundation, I have TCPIP model playlist where I'll explain networking concept step by step in a simple and practical way. So definitely check out those. If this video helped you learn something new, make sure to like the video, subscribe to the channel, and share it much as possible. Thanks for watching, and I will see you in the next one. Until then, enjoy networking.